Well, welcome everyone to today's webinar, Getting Started Using Jump for Teaching. We have one of our academic ambassadors, Ross Matusalem, who will be delivering the webinar today. Something to point out is this webinar series is going to be a little bit shorter than historically we've been doing. The webinar will be about half an hour in length, and then we'll hang out for another 10 to 15 minutes or so to answer questions. So it's going to be a little bit briefer than we've been doing traditionally. Now there's a Q&A and a chat window. If you have a question, type it in the Q&A window. I'm going to be monitoring that along the way. I may also wait until the very end to answer some questions if it seems it makes more sense to have Ross demonstrate something again or for him to answer. There's also a chat window. Try not to put your questions in there. You're welcome to make a comment or some general comment to whether it's us or the audience at large. You can do that in the chat window, but it's easier for us to manage the questions if they're in the Q&A window. There's also a poll up on the screen. We're just trying to get a sense of your experience using Jump. Now, even though this is a getting started with Jump webinar, I can see some people are not just beginners, but are intermediate, and maybe there's even an expert user. Whenever I watch a Jump demonstration from one of my colleagues, I always pick up something new, whether it's a little trick I didn't know about or a resource I wasn't aware of. So I think everybody's going to get a little something out of this. So with that, Ross, do you feel you're ready to go?
You bet, Kevin.
Okay,
Thank
perfect.
you.
All right, take it over.
All right. And thanks everybody for joining this webinar, where our goal really is to enable you to start teaching with Jump Student Edition. So this really is aimed at folks that have little to no knowledge of Jump Student Edition other than they know they're going to start teaching with it. And so by the end of this webinar, you'll know enough about how Jump Student Edition works to get started using it. You'll know how you and your students can get it at no cost. You'll know where to go to learn more, the specific analyses that you're going to do in your course, and where to go to find our library of teaching resources and what you can expect to find there. So let's get started first by talking about what Jump Student Edition even is for those folks who maybe have heard of it, know they're going to use it, but really don't know anything else. And I generally like to show what Jump Student Edition is via some quick data analysis. And so that's how we're going to start. Right here, we have the Palmer Penguins dataset. This is a popular dataset. It's freely available online. It also comes bundled in Jump Student Edition. We have data on several hundred penguins observed in the Palmer archipelago of Antarctica. You can see we have information like the island at which the penguin was observed, its species and sex, and then a few anatomical measures like its bill length or its body mass. So let's get just an idea for what Jump Student Edition is and what it can do by doing some quick analyses. Don't worry too much about the details of the analyses or how I'm doing them. We're going to talk about how to navigate the interface later. This is just to boost your intuition for what kind of tool this is. So if I have a brand new data set, and certainly if I'm teaching, introductory statistics, we're going to get started with just simple univariate summaries. So let's do that real fast. Let's take a quick look at each of our variables. So Jump's point-and-click software, it's made to be pretty easy to produce graphical and statistical outputs in just a few clicks, like I just did right here. So here I have a univariate report on all of the variables in my data set. You can see I have things like the frequencies of the different species observed, or over here I have mean and standard deviation and confidence interval on the bill length measure in millimeters. Jump's highly visual. You can see we have bar charts and histograms that come for free as part of this report. And then everything in Jump is interactive as well. So let's say I'm interested in the Gen 2 penguins. I can just click right on them and see them highlighted everywhere else. I might learn that, they were observed exclusively on Biscoe Island. In my sample, I have approximately equal proportion of male and female penguins of the Gen 2 species. Looks like they're actually on the higher end of the bill length and so forth. So interactive, visual, statistical outputs, all with just a couple clicks. This extends from basic to intermediate and advanced analyses. Let's say I'm teaching multiple regression, and so I pop open our Fit Model platform, which is for regression modeling, and I'm going to build a quick model of body mass regressed against species. Let's do sex and bill length as well. I'll go ahead and click run, and again, in just a couple clicks, I have a wide range of statistical outputs. But what makes JMP Student Edition special, again, is the interactive visual nature. And so here I have a model profiler where I have a graph for each one of the 3 effects in my model. And I can click and drag inside the graph to change the input values or the X values and then see the predicted body mass value on the left axis here. And interacting with something like this, where I'm changing the bill length here, can help make things like parameter estimates, in this example, a little more intuitive or perhaps approachable for students. Let's just do one more. I said that JMP packages basic to advanced analyses in this visual interactive interface. Let's say that what I want to do now is more advanced. I have 4 anatomical measures here, and I want to collapse those down to just 1 or 2 measures of how, big or small or a penguin is, to be able to use that for some further work. So this is a problem of dimensionality reduction. If you're familiar with principal components analysis, we could do that here. That's just going to take our 4 variables and combine them down into a smaller number of variables that retain the information. We can see here, if I pull up a particular output, the eigenvalues in this case, if I go from 4 variables down to 2 new ones, 2 principal components, I can retain 88% of the information in those 4 original variables. And again, interactive graphics. If I look at a plot of these new variables that I've derived here, I notice there's a cloud of points over here, and it turns out, oh, those are all the Gen 2 penguins. So it looks like I'm capturing some size or anatomical difference of the Gen 2 penguins versus the others. Or I could click and drag from the bottom, and if I look at sex, I'll notice, oh, this second component on our y-axis seems to be distinguishing females, which are at the bottom, versus males at the top. But the point here isn't principal components analysis. Part of it was just to show a slightly more advanced analysis beyond regression and univariate statistics. But the main point here is that no matter what kind of analysis we're doing in JMP Student Edition, it's point and click, easy to get to the outputs, and involves a lot of interactive visuals that make data and statistics more approachable for students. And so if I had to summarize what JMP Student Edition is, that's basically how I would do it. Interactive visual, it's point and click, or as we say, no code, and it's for all academic use. Now, some details you should know if you're going to be teaching with JMP Student Edition. I'm on my MacBook Pro here, and the software is available for both Mac and Windows, and it operates the same way on both operating systems, and it runs locally in memory on your desktop or laptop. Now, some folks hear the name JMP Student Edition and think student means feature limited, and it doesn't. JMP Student Edition includes all of the capabilities in our commercial products, JMP and JMP Pro. You can find out what those capabilities are by going to jmp.com/capabilities. So if we do that now, I'll just show you what to expect when you get there. You'll find some main categories at the top in these initial links, and then individual statistical capabilities or techniques listed below. So here in advanced statistical modeling, you can see a collection of multivariate techniques or advanced regression techniques. As we go down, you'll find more basic data analysis and modeling, specialized things like consumer research. If we get down here, data exploration and visualization, I do want to point out as well a full suite of design of experiments tools. And as you scroll through this to learn more, you'll notice that a lot of these have a little icon that says Pro next to them, which means that in our commercial software, this technique would require JMP Pro. Everything that you see on this page, including the Pro capabilities, are included in JMP Student Edition. So it is a full-featured software. And despite the name student, it's not just for students. It is for instructors, so whether that's professors, adjuncts, lecturers, it's for students, it's even for academic researchers and for any academic use, teaching, learning, and academic research. And it's completely free, it's available at no cost, and it's renewable every 12 months. So you can get a license, and then at 12 months, if you're still at university, you just renew and get another 12 months. And I'll show you in just a moment where to go to do that. But first, I'll address one other question that I get frequently, and that is Jump software really just a teaching tool, or is it really just for academia? Is it used out there in industry? Who uses it? Jump software is used by major companies all over the world. And if you're curious in learning about some of those companies and what they're using it for, you can go to jump.com/success. And this takes you to our customer stories here, a featured one now being from a semiconductor manufacturer, JSR Micro. But as you scroll down, you'll find a number of others as well, including perhaps some major companies that you and or your students have heard of, like DuPont or Procter & Gamble or Nike. You can also browse these by industry if you like. And I just point this out for those of you who want to learn about what types of things Jump's being used outside of the classroom for. And this is something that might be of interest or important to you or your students, because ultimately Jump is great for teaching statistics, statistical thinking and problem solving, but it's actually a concrete skill that might help students get a job someday. Now, finally, how do you get it? Well, you just go to jump.com/student. So if I go there, I'll find this button that says Get Jump for free, and I just click there to get started. You, your students, your colleagues all do the same thing. And that will walk you through the process where you'll be able to sign up for an account with us, verify your academic status, download the software onto your computer so that you can install it. You'll also find a link to our FAQ page. I've included that actually right here in this file on the left, which if you're not familiar, this is a Jump journal. It just has notes and links and data sets for today. After the webinar, you're going to get a link to view a recording and to download this journal file. So go ahead and use these links right here, and you can get to the FAQ page, which will cover things like the Student Edition's capabilities, the eligibility requirements, and so forth, and also have a link to the installation guide, which is the second link provided here in the journal. This just takes you to a PDF that walks you step by step from landing at jump.com/student all the way through the installation. I highly recommend providing this for your students so that they have an easier time getting their hands on the software. So that's enough about what Jump Student Edition is. Now let's talk about navigating the interface. I started out with this data set, Palmer penguins, and doing 3 different analyses. And you may have picked up that the workflow for each analysis was kind of the same. And I want to make that explicit for you now. But before we do, let's actually talk about where each analysis starts, which is the data table itself. And if you're using Jump for Teaching, you're probably providing data sets to your students. So let's talk about the Jump data set, Jump data table. If you're coming from spreadsheet software, or certainly your students might be most familiar with, say, Microsoft Excel, you might want to point out that a data table is a little different. It has a structure to it with 1 row per observation, in this case 1 row per penguin, and 1 column per variable. So a column for the first penguin's island and species, sex, and so forth. And this contrasts with a spreadsheet where every cell is completely independent and you can type any information in there. But Jump Student Edition and other statistics software requires this structure of 1 row per observation, 1 column per variable, so that the software knows what to do with the information it finds in each cell. You'll also notice that each variable or each column is treated a little bit differently. For example, we have header graphs at the top of the data table here. And if you're not seeing those in your version, just click this little gray bar icon near the column headers to open or close them. And you'll notice that for island, species, and sex, which are categorical variables, we have these bar charts with these labels. And then for our continuous variables, these anatomical measures, we actually have histograms with minimum and maximum values. And this is because each column has associated with it what we call in Jump software a modeling type. So think continuous versus nominal versus ordinal variable, and there are some others as well. It corresponds to these icons that you can see in this part of the data table right here. So these red bars indicate a nominal variable. The blue triangle indicates a continuous variable. There's also ordinal variables, which will show green bars. You'll notice as I changed bill length to ordinal, it actually even changed the graph type up here to that labeled bar chart. JMP uses the modeling type to decide what graphs are appropriate, what statistics should be calculated, and so forth. So it's important to make sure that the modeling types are set up correctly. This is just one setting for a variable, and there are many others available if you right-click and go to column info. So I'm going to right-click on bill length and go to column info here. And I can do things like easily change the name of the column, change its modeling type, maybe change its format if I want to have a fixed decimal, everything out to just one decimal place, or a whole lot more under this column properties list. For example, I want to specify axis settings so that every graph JMP produces with the bill length variable obeys a certain minimum and maximum and maybe tick increment. Or maybe I'm teaching statistical process control, and so things like spec limits and control limits are important for me to hard code with that variable. Many different things that you can set up so that JMP treats that variable or that column the way you want it to. And I recommend if you're creating data sets to give to students to go ahead into this column info section and make sure you have things configured the way you want so that students can use the data the way you intend them to. Now, there's more to know about the data table. As you can see, there are some other sections to it, like this top section up here we're going to talk about in just a little bit, or the summary section of rows down here. But this is enough to get you started, to just know the structure. It's a data table, not a spreadsheet. That each column has the modeling type, and that's going to affect what JMP does, the types of statistics it produces for each column. And that if you need to set that or other things with respect to those columns, just right-click and go to column info. Now, once your data table is ready to go, any analysis that you want to do is really going to follow the same basic steps, no matter if it's a simple univariate analysis or maybe you're even doing some advanced predictive modeling or machine learning. This is what I'm referring to in this journal as the JMP analysis workflow. So let's see what that is. And for context, let's say that what we want to do is a one-way ANOVA. Okay, so I want to look at differences in body mass across these three species. So the first step is to launch an appropriate tool, or what we call in JMP software a platform. So if I want to analyze data, I should go to the Analyze menu. If you're coming from other stat software, you might look at this and say, well, where is one-way ANOVA in this menu? And you might not find it. Instead, you find things like distribution, fit y by x, fit model. Hover over any one of these and you'll get a tooltip that tells you what this tool does. You can see fit y by x models the relationship between two variables. That's what I want to do, so I'll select fit y by x. Next, I want to fill out the launch dialog that appears, which provides me a list of the columns in my data table on the left and the roles they can play in the analysis on the right. So my X is species, my Y is body mass, and I'll click OK. JMP has produced a default analysis report. In this case, it's just a graph, a dot plot for each of the three species with the overall mean marked on the y-axis here. And so if I want anything beyond the default output, I request it using the red triangle menu that you're going to find at the top of the window. In this case, I might click means in ANOVA to get the ANOVA output below. So the nice thing really about this kind of interface where you launch a platform, fill out a launch dialog, and then request things from this red triangle is that you can always just request more on the fly as you need it, instead of filling out a massive dialog with every possible analysis you might want before you get any output. So here, if I wanted, let's say, unequal variances test, I could just now request that. Looks like maybe we do have evidence of unequal variance. Or if I wanted to do follow-up comparisons, then maybe I would go to compare means and select each pair student's t. And you're going to notice here too that all of the options under the red triangle are appropriate specifically for a situation where we have a categorical x and a continuous y as specified by our modeling types here. If I were to relaunch this tool, fit y by x, and say, let's take a look at body mass by flipper length. So now it's continuous by continuous. The options here have changed, and I have things like fitting the regression line. Again, modeling types playing a role in what is available. But no matter what you do in JMP, It's this same basic workflow. So to go back to our distribution platform, if I were to do univariate analyses, again, I get my launch dialog, click OK, get into the default report, and then for any individual analysis or variable in this case, I can just click the red triangle to request more. In this case, maybe I would request a 90% confidence interval instead of the standard 95% and have that added right here. So no matter what you want to do in this analyze menu, whether it's something simple or whether it's more complex like the principal components analysis we did, or maybe even doing something like building a neural network model or structural equation modeling, you're going to find the same basic workflow. And with each JMP analysis platform or report, you're going to be provided with interactive graphics for exploring your data. In fact, it's even back in the data table. We've seen some examples of these. I can select in a graph of the species, the Gen 2 penguins, and see their points highlighted everywhere else. Everywhere in JMP, you're going to find these interactive graphics where when you select some observations or some rows, those get selected everywhere. And it makes data something that students can interact with and explore in a way that you just can't with static graphics. And the best way to do that, I would say, is through our tool Graph Builder. So Graph Builder is drag and drop graphing. If I want to look at, let's say, the relationship between bill length and depth, I can just put bill length on the Y, depth on the X, and maybe even select the type of graph I want. In this case, we'll put the linear regression line. And so imagine I'm a student looking at this and I'm saying, wait, looks like the line goes down. That's weird. I would think if one dimension of a bill's size gets larger, the other should get larger. The line should be pointing up. Well, with interactive graphics, you can explore these data further to try to figure out what's going on. In this case, maybe a student notices that there's a particular cloud of points right here. And then back up in our species graph, we can see, wait, those are just the Gen 2 penguins. And if I go down here, oh, those are just the Adelie penguins, which means that these ones right here are probably the chinstrap penguins. And sure enough, they are. So maybe what I should do instead is put species into this graph as well. And now we see a sensible result. If you've ever heard of it, this is actually something known as a Simpson's paradox, where in aggregating across the three groups, we had a false impression of what the true relationship is. But the bigger point, again, is you have interactive graphics everywhere in JMP, and it makes data something that students can interact with and explore in a way that wouldn't be possible otherwise. And those are the things, the analysis workflow and the interactive graphics, that I think are foundational to JMP's interface and that you're going to find ways of using over and over again. Now, briefly, let's talk about importing data and saving and exporting results. To import data, if you have a JMP data file, which is a .jmp extension, you simply double-click it and it'll open in JMP. That's probably familiar to everyone. But know that you can open many other file types, like Excel files, text files, and so forth, by going to File Open. Down here, I provided a link to the documentation specific to importing various file types. And so here, under the contents, you can actually find the files that you might need to import in your class. Often, if it's bundled with a textbook, it'll probably be an Excel file or a text file. But we have support for many other file types as well, like PDF, XML, JSON. You can also query databases, import data from the web. I put some more information for tools for doing that in the journal right here. For most teaching, though, I think you'll either start out with JMP data tables if you're getting them from our team or the software or a book that bundles them. Otherwise, Excel and text files are probably where to look at. But again, just remember, File Open is all you ever need to do, and JMP has bespoke tools for importing a lot of different file types. Now, for saving and exporting your results, there are two recommendations I have. The first has to do with saving your results in JMP to be able to reproduce them. So here is a multiple regression model that I built on these data, and you'll notice that I just pulled it up by clicking a little green button in my data table right here. And what this was a chunk of code, JSL, JMP scripting language, that actually runs the analysis on the data table when I click that button. Anytime you run an analysis in JMP, you can go to the red triangle, find the Save Script submenu, and then go to Save to Data Table. I'm just going to put test in all caps here. And you'll notice that it gets added to the data table right here so that when you click the green button, that analysis is rerun. You never, and your students never, have to interact with the JSL code, but you have the benefits of reproducibility that code provides. This is the way that I recommend saving all of your work inside JMP as opposed to going to File and saving a report as an external file. Now, if you do need to get your results out of JMP, and if you're teaching, I imagine you do, students might be putting graphs and outputs into documents or slides. Just use File Export, or you can copy paste. So let's say, for example, I have a graph. I'm a student. I've made this graph that we saw before, and what I want to do is put this into a document or slide. Well, I can just right-click and go to Copy Graph, and then paste it in Word or PowerPoint or whatever it is we're using. If so, I just recommend using vectorized graphics formats whenever possible. So on Mac, PDF, on Windows, EMF, just so you don't get any blurry stuff or pixelation. But these are the two things to remember. Save scripts to your data table to be able to reproduce things inside JMP, and then either just go to File Export or use Copy Paste to get results out of JMP. The one thing you don't ever have to do is take a screenshot. There's always a better way to get something out of JMP. Now, I've talked about how to navigate the interface. I've not really gone into any detail about specific analyses. And obviously, if you're teaching with JMP, there's specific analyses that you are going to cover in your course. So to learn how to do those, I have a few recommendations. The first and the quickest is to go to jump.com/learn to find our learning library. So if I go to jump.com/learn, organized by category, you'll find links to quick tutorials on a number of common analyses and graphing techniques. For example, we looked at one-way ANOVA earlier. If I go to basic inference on proportions and means, I'll find the one-way ANOVA tutorial. When I click there, I land at a page where I have a 2.5-minute video that shows step-by-step. I'm not sharing the audio right now, but shows step-by-step how to perform that one-way ANOVA with fit y by x, some of the follow-up things you might do, and some of the ways in which you can interpret what you're seeing. So a very quick way to learn how to do something specific. And each one comes with a PDF guide with step-by-step instructions to retain after the fact, just for your reference. I highly recommend using these for your own learning and also sharing the learning library with your students. So if they ever say, hey, how do I do that one-way ANOVA? You can say, just go to the learning library. Now, specific for you instructors, you might want a deeper dive on the things you're teaching. You know, a deeper dive on teaching regression in ANOVA, where I or Kevin or a member of the JMP team walks you through things in greater detail. Go to jump.com/webinar to find our academic webinar library, where you'll find a number of webinars specific to teaching certain techniques with JMP. For example, if I clicked regression and ANOVA, it'll take you to a description of our teaching regression and ANOVA webinar, and then you can click watch the video to be taken to the page with the on-demand recording and the link to download the JMP files that we used. Now, finally, we have a new addition to our suite of resources for learning how to use JMP, and that's the JMP Learn Bot, which is an AI-powered JMP tutor. You download it from us at our JMP Marketplace, and when you do and install it, it'll pop up here at the top of your help menu. This is a custom GPT that's been trained on all of JMP's help resources, so I can ask it things like, how do I do a one-way ANOVA? And it will produce step-by-step instructions telling me exactly what to do and giving me some basic help in interpreting the outputs. And it's conversational, so I can follow up with another question. What about testing for equal variances? And so now I have the flow for that. So the JMP Learn Bot is a great way to learn JMP yourself, and also for students to be able to have on-demand, customized help built right into the software so that they don't get bogged down or stuck. click this link to go to the page where you can access the LearnBot at the Jump Marketplace. It's a free add-in. You just click here to download it, double-click the add-in file, and you can install it and have it living at the top of your help menu. Now, finally, before we take some questions from the audience here, I just want to highlight our library of teaching resources that are available to you, some of which are built into Jump and some available online. But all of these resources can be used to enhance your course or maybe lighten your load by providing you with data sets or exercises you can just use right out of the box with your students. The Student Edition comes with a student menu that has a collection of interactive teaching applets, statistical calculators for those back of the book problems, do a t-test where the mean was 10, the standard deviation was 2.5, and the sample size was 15. Really, I love these applets that we have up here because they provide interactive simulation-based demonstrations of statistical concepts. For example, let's take a look at the confidence interval for the population mean. Here we're trying to demonstrate, in this case, to students, what 95% confidence actually means. So we're going to draw samples from a IQ distribution with a mean 100, standard deviation 15, sample size, let's say, of 30. And when I draw one sample, I'm going to see a histogram for the sample here, some summary statistics, the confidence interval, here's the lower and upper bound right here, and then a plot of the confidence interval. And I can see it's green and it overlaps the value of 100, the true mean. So far, all of the one confidence intervals that we've calculated from our sampling contain the true population mean. But if we were to repeat this procedure, we'll notice that some of them popping up in red actually don't contain the true population mean. And this value starts to converge at around 95%. In fact, if we do this many more times, let's say 10,000, we start to see that it converges to 95% pretty quickly. And of course, I could go on and maybe change sample size and see what the effect is on the width of the confidence intervals, or change the confidence level and see how it changes this value. But the point really isn't this particular tool. You can watch some of our other webinar content to learn how to use these. It's that we have a range of these interactive applets for teaching statistical concepts, in addition to all the tools for actually analyzing data. Now, finally, the last thing I'll show you at jump.com/teach is our library of additional teaching resources. Go here to find suggestions for books you can use that integrate Jump. These step-by-step guides right here will take you to our learning library that we already saw. Our case studies are a collection of real-world data analysis problems with multi-step solution paths, Jump instructions, data sets for students to use, and even exercises for them to hone their skills. And a number of other resources as well. For example, our enhanced data sets, which are sample data sets that come with full documentation like data dictionaries, background for why the data was collected, and suggested exercises. All the resources you find here can be really valuable for, enhancing your course with things you might not be able to build, at least in a reasonable amount of time yourself, or to just lighten your load if you need a good data set to use for an example you want to do in class. And so with that, let's wrap up. So even if you knew nothing about Jump Student Edition, hopefully now you know what it is, how to learn about its capabilities, how to navigate the interface, and how to learn more and find more resources that you can use to master the software, teach your students how to use it, and also to maybe enrich your course a bit. So thank you for your attention, and we'll just open it up to Q&A for the rest of the time we have here. So Kevin, are there any questions that have come through that would be good to answer live?
Okay, thanks, Ross. Great overview introducing to Jump. And as I said at the beginning, I always learn a little something, even as experienced as I believe that I that I am. There's no pending questions at the moment. The only two came in that I answered along the way. But yes, let's see if anyone has anything more. And I don't have anything right after this, so I'm free to hang out as long as anyone needs.
Great. And likewise, yeah. So we'll hang here for a minute to answer any questions that come in. Oh, all right. I have it pulled up, Kevin. So take a stab at this one. It says, thanks for a great introduction. Can a user change line colors on the output graphs? Indeed, they can. So we have a whole webinar on publication quality graphics and customizing your graphs, but let's just take a quick look. I'll go back to Graph Builder. Let's see if I recall, we should get back to this graph. If I wanted to change any of these colors, I could right click inside the legend, in this case on the Gen 2, and choose a different line color. So instead of red, let's say I want it to be yellow. Now we have yellow. Now that's just a one-off. Maybe I don't want to do that every time. We didn't see the jump preferences, but if you go to the jump preferences, you will find things like the graphing preferences where you can set all kinds of color defaults for you. And then that will apply to graphs all over jump. So you can do it ad hoc, or you can change your defaults. All right, now I'm seeing more come in, Kevin, so maybe you can start feeding them to me.
I'm helping someone with.
Oh, okay. No worries. If you're typing, then I'll find one. Let's see. Is there a source that outlines a curriculum or unit plans that walk a stats or engineering teacher through the use of jump? Let's see. So we have on our teaching page, I'll just point you to this for that kind of resource. So we're back at jump.com/teach. Down at the bottom, check out our full course materials and on-demand courses on specific topics, for example, design of experiments, or our statistical thinking course, which has modules on things like exploratory data analysis, quality methods. This is really inference. We call it decision making with data, correlation and regression, design of experiments. These would be more structured sequences of learning activities that you could use in order to master the things that you need to. Or I actually know some faculty that assign these modules or other jump courses to their students, so the students complete the modules at home and then come in a flipped classroom-like model to do exercises in the classroom. All right, let's see. Kevin, are there any others? I'm looking around.
Yes, I'm typing. Someone's asking a question about getting help using Jump, and I wonder if you can. I know we're going to cover this in another webinar, but maybe quickly show the LearnBot, or at least show that it exists.
Oh, well, we saw the LearnBot earlier, but I can do another quick example. So here's the LearnBot, and it looks like this person is interested specifically in helping understand the results. So let's say, for the sake of time, I'm not going to pull it up. I obtained a p-value of 0.04. What does that mean? And this is kind of dangerous. I've never asked this exact question of the LearnBot, but let's see how it does. Well, here's an example here. It says the p-value of 0.04 indicates the probability of observing your sample data or something more extreme, assuming the null hypothesis is true. That probability is 4%. It's relatively low. The observed result is unlikely to have occurred by random chance. And then it even goes on to describe statistical versus practical significance, the risk of error. Let's try one more, actually. We looked at principal components analysis earlier. So let's say I did PCA and got an eigenvalue of 2. What does that mean? Again, a question I've never asked LearnBot before, but let's go. All right. In PCA, an eigenvalue represents the amount of variance in the data that is explained by the principal component. An eigenvalue of 2 means the corresponding component accounts for 2 units of variance in the data set. And then it goes on to explain exactly kind of what that means. So you can use the LearnBot to help interpret things as well.
There's one question, Ross, where a person's asking how to put a square box with a pointer, and I wonder if I always get this whenever I'm using the Demo Pro thing. They think it's a jump.
Sure. Yeah, so this person asking about the squares and pointers is probably referring to something like this that I did earlier, and I can annotate. This is actually a third-party app. There are third-party screen annotation apps that you can download if you want, but you don't have to. Actually, there's something as well. So let me pull up a jump window. So let's say I wanted to highlight this frequency table for students, and I'm drawing inside Jump. Now, you can actually do freeform drawing like this by using what's called the Jump laser pointer. So I'm going to go back to our Jump preferences. I believe it's under reports. Yes, but you could also search for laser pointer. And you'll find this laser pointer option right here. I have mine set to purple. Let's go to blue just to show you. Okay, so you can change the color, but the basic idea remains the same. and that is that you can actually start drawing on top of jump windows by holding down your mouse. So if you don't want to get an extra, uh, third-party app, you can just
I
use the.
used to say, if I hear AI,
Interesting. I just heard somebody off mute there, but I don't think that's
Yeah, no,
possible.
I was grabbing a webinar for somebody on YouTube, and it
Oh, I
started playing
see.
the commercial for someone's asking what time series, and I'm just collecting up some resources we have on
Gotcha.
that.
Okay. Yeah, that's funny. I've never heard audio come through that crisply through
Yeah.
a microphone on Zoom before. It sounded like somebody was sitting next to me in my home office. That's great. Um, okay, so that was how to make the square box. Somebody says, can I use Jump to teach forecasting methods at a progressive level? You absolutely can. So I'll just point you to
Oh,
under the Analyze menu, Specialize Modeling. You're going to find Time Series, which does all of your basic, smoothing methods and ARIMA style models, and then also Time Series Forecast, which does more of the state space models with automated model selection.
and
But you absolutely
Carlos.
can.
Oh, sorry, Russ, I didn't mean to cut you off. And
That's
Carlos,
fine.
I'm dropping in. I'm going to send in a sec. I'm dropping in some links for you of some recordings and webinars that we have on that. So stand by. Hold on.
All right. And while you're typing that in, Kevin, I see one more question that had come through as well in the Q&A, and it says, for a non-statistical person like me, where should I start? Any recommended books or resources would be great. So I'm going to, again, just go to, let's see, let me get my browser window back up here. Where did it go? Under jump.com/teach, and point you to the full course materials and on-demand courses. So the statistical thinking course that I showed before is really great for just getting started. It assumes no real statistical background, and it's really applied and conceptual. It's not going to hit you with a bunch of equations and theory. You also have our on-demand courses created by our Jump education team. And so you can take our Getting Started course, which is really just a more detailed version of some of the stuff we talked about today. Or maybe you want to learn about a regression in ANOVA or maybe design of experiments. Those are the resources I would suggest for getting started.